Hi everyone, my name is Pedro and I'm a EuroTech postdoc researcher. Today I'm thrilled to share some exciting insights of my project in enzyme technology. Did you know that plant cell walls are made of three main building blocks?
Lignin, along with cellulose and hemicellulose, forms the structural framework of plant cell walls, providing the necessary strength, flexibility and support for plant growth.
This combination allows plants to withstand external pressures like wind and gravity. From towering trees
To tiny shrubs and grasses,
lignin strengthen the structure and contribute to the resistance to decay and microbial attacks.
lignin is the second most abundant renewable carbon source, and it makes up about 30% of the non-fossil carbon on Earth. That's impressive. Traditionally, it is considered a low-value waste product, so burning residual lignin for energy has been a strategy to avoid the challenges of dealing with the high heterogeneity and difficulties of isolating this polymer. However, using the right technologies, lignin can be used as a renewable resource to produce biofuels, chemicals and other high-value products.
Want to know more? Come with me to the lab. I'll show you around.
My work is developed at DTU, the Technical University of Denmark. In our research group, we aim to understand how nature deals with lignin conversion, as this is our best chance of directing biotechnology towards solutions to obtain high-quality carbon for future needs. In my project, I investigate the role of glucuronoyl esterases in biomass deconstruction. These esterases are part of the enzymatic machinery involved in breaking down lignocellulose. They target the ester bonds between the sugars and lignin, loosening the structure of the plant cell wall.
The overall goal of my project is to understand how these enzymes interact with lignin and thereby answer how to harness nature's tools for the development of more sustainable industrial processes.
Glucuronoyl esterases are produced by a variety of microorganisms, including bacteria and fungi. Different microorganisms may produce unique types of enzymes with varying substrate preferences. After purifying an enzyme, I set up hydrolysis reactions using biomass as substrate. Each tested enzyme will prefer specific conditions that result in different hydrolysis rates. Some of these parameters include temperature, pH, and the type of biomass. I take the soluble products and employ liquid chromatography coupled to mass spectrometry and ion chromatography. Using this method, I can measure how effective the enzymatic treatments are in hydrolyzing the biomass. So far, our findings reveal that various enzymes originating from the same organism exhibit distinct activities. This suggests there's a possible evolution to address diverse conditions or even possibly different substrates. We expect to make lignin extraction easier, resulting in better quality lignin for further processing.
Understanding lignin's properties and potential applications help us manage resources sustainably and develop greener technologies. Using these enzymes is an alternative to traditional chemical methods for lignin utilization. And by doing this, we're not just learning about enzymes and lignin, we're also providing actionable insights towards a more sustainable future. Sounds interesting? If you have any questions or want to know more, please feel free to comment below. Thank you for joining me on my research project. Together we can make a positive impact for a greener tomorrow.